Good morning, everyone. We welcome you, Dr. Sunil Kumar Das, sir. Dr. Sunil Kumar Das is an associate professor at Father Francisco Rodriguez College of Engineering. His education Masters of Engineering in Mechanical. He also holds a PhD degree. He has 25 years of plus teaching experience of 5 years in research, and 4 years of industry's experience. His areas of expertise include advanced manufacturing, CAD, CAM, and many more. He has guided more. Welcome, sir.
Audible? Hello.
Yes, sir, you're audible.
So, on the
Next, we would like to welcome Ms. Maria Ali Khan. Maria Ali is an accomplished product manager with a diverse background in software engineering and entrepreneurship, currently serving as a product manager at Microsoft Azure Snap's data warehouse. Maria has an extensive experience in developing innovative software solutions that drive business growth. Prior to her role at Microsoft, Maria spent 2.5 years at IBM, where she served as a product owner and software engineer, gaining valuable insights into tech industry. Maria is also co-founder of Women in Cybersecurity, Georgia, a non-profit organization that promotes diversity and inclusion in cybersecurity. Her passion for technology is evident in her educational background, having completed a master's in electrical and computer engineering from Purdue University and bachelor's in electronics from Father Francisco Rodriguez College of Engineering with a unique blend of technical expertise and business acumen. Maria is a dynamic leader in the tech industry and a driving force behind innovative software solutions.
Hi everyone. Hey Isha, is the first team on? Just want to make sure people can hear me.
Sorry for the delay, but we are waiting for the participants to join.
No worries, it's all good.
Tanisha, if you're ready, you can start with the presentation.
Get ready. Hello, Ethan.
Yes, sir.
Have some schedule, right?
So we have shared the schedule. They are joining now.
Okay. They have been given time. Time slot is given to them, and any
Yes, sir. There. Yes, sir. There will be time.
and time limit is also given.
Yes, sir.
Start at the place. No? If not, just send the next group.
Okay. Shall So good morning to everyone present here. The topic for our project is design and analysis of an artificial mechanical heart. So the group members are Joel Sam, Rachel Zalwani, myself, Kaviraj Iswaran, and Yash Rotlikar. So the objective of our project is to understand the function of a human heart and how the heart behaves under extreme conditions, stress, or any high body demands, the behavior of the heart, and to mimic this function due to organ transplant, because organ transplant is a very important field. Not much research has been done on total artificial hearts, especially in India. So a human heart can bridge the gap between finding an organ donor, or even during a surgery or any crucial crisis. So another objective of our project is mimicking the performance of the human heart and performing the structural, fluid, thermal, and hemodynamic analysis. This is the model that we have created this is the 3D CAD model that we've created in a modeling software called SolidWorks. This is the internal part, which means that it is hollow in the section shown. Those are pipes attached. This is the cut section of our design. Our design is actually based on pneumatic pressure. So pneumatic pressure will be given through the chamber that is on the left, and one bar will be given. The oxygenated blood and deoxygenated blood have two chambers, one on the left and on the right. So as the blood enters during suction, the pneumatic valve will expand, and once the pressure is removed from the pneumatic valve, the blood will exit through the pipe on top. This is the final design of the SolidWorks model, which is on the left, including bileaflet valve. Bileaflet valve is used when we only want one-way flow control. That is, the backflow of the blood should not occur, and that is why we will be placing all these inside on all the ports. This is the design before, and this is the after design, which is the finalized design using flexible material. This is the bileaflet valve that we have created. Over to Yash Rotlikar.
Good morning, everyone. So, so we performed an analysis on our project using the software called ANSYS. So this shows how the meshing of the model is done to perform the analysis and find the total deformation and equivalent stress and other criteria. So this is our ANSYS flow diagram, analysis flow diagram, which we use. So first we perform the fluid flow analysis for the flow of fluid through the chambers from the inlet and outlet, and then we link the results from the fluid analysis to the static structural analysis to see how the flow of fluid affects the solid part of the heart. And that the other image shows the eddy viscosity of the analysis, which gives us the turbulent energy transfer of the fluid. Next. Okay, so the pneumatic pressure inlet profile. So that shows us the inlet and exit profile of the blood. So we use the fluid properties same as blood. Since we know that blood is a non-Newtonian fluid, which does not follow the laws of viscosity, as the viscosity changes when different stresses are applied. So we cannot use basic water as the fluid. So we change the properties of the fluid similar to blood to perform the analysis. And so what we and this shows us the fluid profile of the flow, and we have provided a pneumatic inlet as well of 1 bar. And the above image shows us the deformation. So this is the fluid setup, which shows us how the inlet and outlet of the blood is going to take place, and this is the database for the properties of the material. Yes. Yeah. So the above image is the cut section of the heart, and we have the green part of the image is the pneumatic inlet. So as we told before that we have transferred the data from the fluid analysis is the transfer of data and how it is affecting the solid part of the heart. Yeah, profile of the blood, which shows the flow. Next. This is the material properties. See, since we have used the TPU filament, these are the material properties for that. And this is the actual prototype of the heart which we printed. So this is the 3D printed heart which we have printed using the selective laser sintering method, SLS method, and we have used a material called Flexa Black, which is compatible with that machine, and it provides the flexible properties needed in using the TPU material. So now Kaviraj and Joel will explain the business model and costing part.
Good morning, everyone. My name is Kaviraj. So our business model canvas includes basically our project is like we have two chambers instead of the biological four chambers, and one we have a pneumatic chamber. So what we're trying to do is rather than placing it inside the human body, we will be placing it externally, and we'll be bridging the gap between the queue of heart transplants required and the patients waiting for heart transplants. So our key partners may include research laboratories because a lot of research is required for this. We are still in the initiating phase and we have not completed the entire research. But according to our final year project, we have covered more than what we should have achieved. And the second key partner that we feel is very eligible for us is that hospital and medical sectors. The main attraction for this project is that it is available at a very reduced cost rather than the heart transplant. And due to this, we can promote awareness regarding various heart ailments. We can curb queues for long heart transplants, and then we can actually, since most lot of our research is required to place it externally, we have only 3D printed it, and we are actually planning to 3D print an actual scale. Uh, Carrying forward to Joel.
We can't hear you, Joel, if you're speaking.
Hello. Hello.
Yeah, go ahead.
Yeah, yeah. So yeah, we'll need a okay, yeah. We'll need a laptop for the designing and the analysis part, a SolidWorks license, and one ANSYS license. So the costing is coming around to be like a lot, but actually we use the student version for both the softwares, so this can be reduced. So Rachel, go down. Yeah. So the 3D printing cost. as we use a Sinterit Lisa Pro, the 3D printer, the cost of the is coming out to be 8,65,000. So the powder that we used for the and a powder sieve to like get the powder out. Like if we have some powder left, so we can use that. The final model can be then later. Hello, hello, can you hear me? Hello.
Yes, I can hear you.
Yeah, sorry, my network issue. Sorry, sir. So yeah, so these are the things. The powder tools. We need powder tools, as in a funnel, a trowel, a powder management tools, like to use the powder that is left up in the SLS machine. A liquid polymer coating will be needed for the end model. Like you saw that black heart, we can use that as a, like we can coat liquid polymer over that to get a proper finish. And the maintenance of the machine, which come out to be around 67,200 for a year. Yeah. So this is one method. The other method is injection molding. So in injection molding, we can use gallium model B100. That is a machine that can be used for injection molding. We can use electrical discharge machining for molds. So the costing of like the hourly basis, if we count out, calculate, we'll be getting around 2,77,200. So like with using TPU material and the labor cost, the entire cost will come out to be around 7,80,000 for injection molding. So if you go and see the final costing, the 3D printing cost will come out to be around 14,69,000. That is including the 3D printing cost and the prime cost, that is the SolidWorks licensing and everything uh, for businesses. And in injection molding, it is coming out to be 18,30,000. So uh, if you like,
Hey Joel, is this cost per deliverable, or is it what scale are you calculating this at?
yeah, the scale is coming out to be like 40 models we can create. This 10 lakh you mean, or the model like if we 3D print it?
You can explain how you came
Okay,
up with
okay,
these
okay,
numbers.
okay. So like if we are 3D printing it, the 3D printing model, like this is a one investment, one time investment, as in for the machine thing. Rest, then the cost will be minimal. That is only for the powder you need. That is 40,000 per bottle, and in one bottle you can create around 40 to 50 models with the dimensions that we are using. So the through 3D printing we can use that 40,000 like per bottle. And in injection molding, the mold cost is like only for once, right? So that is also a one time investment. The electricity charges and all that we use, that is miscellaneous charges. So obviously if you see, yeah.
Okay, great. How much time do we have for questions, Isha or Das, sir, if you know?
Okay.
In fact, I don't know. It's time or it's after presentation only, like we can ask the question. Yeah, anyone from ESL? Hello, ESL? Yeah, as per the format, whether the questions should be asked at the end and how much time they have been given. And can we ask question in between? Okay. They have been given how much time? Okay. 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 Thank you.
Thank you. Is that it on the presentation front? Then sir and I can ask some questions.
Yeah, go ahead.
Okay. Do you want to go first, sir?
No, you ask.
Okay, sounds good. I have a bunch of questions actually. This is a great concept. I heard someone mention that this is your fourth year PE project, which is great. Some basic things I think maybe I missed or I didn't hear about. The heart doesn't only have a function of pumping blood to your body, right? It also purifies blood. So I didn't hear anybody talk about the purification process. I think, correct me if I'm wrong. But regardless, great effort, pretty awesome. I would have loved to see the cost factors being put side by side with how much it costs today for people to get heart transplants and what the market looks like and what the projections are for how much money this could make. I don't know if I'm asking questions on the right track. I'm assuming this is the e-cell, so we're talking about this from an entrepreneurial perspective. So that's why I would have liked to see what kind of money this could make. Also, a bunch of technical questions around how how this model would perform under stress, or how you would design it differently for patients of different age. So those kind of things, I'm sure, in a short amount of time, you may or may not have had the chance to think this through. But if you're planning to go forward with actually researching this with some medical facilities, you may want to think about some of these edge cases.
Can you come up with the presentation? Just show it on the screen. Hello.
Hello. Sorry, sir. Can you please repeat?
Yeah, just put your presentation.
Rachel, can you please share the
Yeah.
presentation?
Is it there? No,
Yes, sir.
no, presentation.
Okay, there we go.
Yeah. Okay. As Maria Madam had asked, that yes, externally, first thing is whenever you just talk about this, right? It's not question of just pumping. There are so many other things. Okay. So did you consider those factors? Am I audible?
Sorry, sir. Could you just speak a bit louder?
Yes. Did you consider those factors? It's not only pumping, right? Hello.
Yes, sir. We have thought about factors in our mind. And actually, for now, we have looked at it as research project only, because since this is the first time we are developing it, we need some more time to think about those factors. And we have done the analysis over the model, and about the age factor, as ma'am said, uh, we have considered it as a standard for the normal age group, like for elders, but for the younger age group, they are not yet thought about as such right now.
Because you see, the thing is,
Also, ma'am, you had asked about the purification, right? So, like, actually, the heart doesn't purify blood. It just pumps blood, and it pumps blood to the lungs. The lungs does the purification. So the two chambers that we have. The one chamber will have the deoxygenated blood that is coming from the body to the heart, and then it will be pumped back to the lungs for the purification, and then the purified blood will come back to the heart and then to the body. That's why we have two chambers.
So the relation between heart and the lungs. Yes.
So I didn't get your question.
No, no, relation between heart and the lungs for pumping. Is there any relation?
So relation as in the arteries, the supra vena cava, the inferior vena cava, all those arteries, veins are all connected, interconnected, right? So
Okay, so when you
from the
keep it outside, as per your model, you are keeping it outside also. Okay, like say suppose a heart transplant is going on, it is getting delayed. So in the meantime, as per your model, you are thinking that yes, it can be used for some time, right?
Yes.
Right. So
Yes,
do
sir.
you believe the gap between that heart and lungs? Will it be in a patient to sustain? That is what. Okay, right. Not only pumping. It is having relations or relations with other organs also based on that, right? So whether your model will survive, model will survive means that the intended purpose itself will not be solved. That's what I see. Right? How do you defend it? What's my question? Okay. You got my question? Can you respond?
So can you please repeat the question again?
So what I said is, as per your model, okay, the applicability is suppose if someone is going for heart transplant, right? So in the meantime, if it is getting delayed, so in between your model would come for the rescue till the heart is there, or heart arrives, right? And what I'm saying is it is having a relation with other organs also. It is not just question of only pumping, right? So probably it may not sustain. Your model will not sustain. Okay, cannot survive, right? It is not going to the way you are thinking. It may not function, and it is going to affect. I mean, the function. What alternative you are thinking of heart? Okay, so it may not function that way. So how do you defend it?
So what you're saying is completely true. The heart is actually linked with other organs as well, but the heart actually has only four outlets, right? Two inlets and two outlets. So those are like, one is inferior vena cava, one is superior vena cava, one is the aorta, and the one is pulmonary artery. So only these four veins are coming out of the heart. So if we actually know the we did research on that, and we know the value of how much blood will be flowing out of the heart, actual human heart. So we got that result in our analysis. There is
Okay,
so
heart
this
is
is
open. Yeah,
open.
otherwise how the
Yeah.
connectivity will be there?
So yeah, once the heart fails, you'll be replacing it, right? You'll be cutting the all the veins, and then you'll be attaching it, reattaching it. Yeah.
That's what I'm saying. That human theater and his heart, I mean, is open. In that
Yeah.
case, only you can connect. Assuming that okay, your model works, right?
Yeah.
Okay, so these are the gaps that we have not addressed. Okay, um, assuming okay, for a moment that okay, this works. Okay, let's go to the next. That is your costing part. Yes, in the costing part, you have shown like what is the economics of this game? What is the economic justification? How do you justify the costing?
So the costing that is coming up so high is because this is a one-time investment for the machines. So like if you buy a 3D printer, Rachel, can you go up? Yeah. So for the 3D printing, the 3D printer cost that is coming out to be 8,65,000 is only one time. The sandblaster is only one time. The powder sieve is also one time. Dedicated powder tools are also one time. So only what is gonna repeat is our powder, the SLS powder, that is 35,000 for 2 kgs. So Rachel up.
So
Yeah.
what?
So 40 products can be made out of
Okay,
that 35,000.
I got it because what the cost you are so. Okay.
Yeah.
So what will be your rate of return? Have you thought about it? And what will be
So
the
ROI.
yeah
So
ROI?
actually,
Oh, no,
yeah. Okay.
rate of return did not return investment. Okay. And
ROI.
what is,
Okay.
what is
Okay.
what is the number that you are expecting?
So I have a rough estimation that is in the world actually there are almost like on a yearly basis uh, at least 5,000 people have sorry, not 5,000 though, like more than that, 10,000 people or more than that, they have heart, like the major problem of people dying is because of heart diseases like heart failures and stuff. So if you see the survey, 5,000 transplants are happening yearly, and in that, only 2,000 people or 3,000 people are getting the replacement of heart, like that.
See,
So
see,
yeah, so 20% people, 20-40% people are like uh, just they are not getting a heart and they are like waiting for the queue, and then it's over for them.
no, that's see,
Yeah,
that's the
that's
story.
a
That's the
yeah.
story. Let's just come to the calculation
Okay,
or the
calculate.
or the data that you have shown. I'm interested now in that. Assuming that your model is correct. Assuming.
Okay,
Okay.
okay,
Right.
okay.
Right. So what is the number of units you are expecting in a year?
In a year to be sold.
Yes.
So around 10,000.
10,000. How do you justify that?
10,000
What is
into
what is
if
the
we like
no, no,
cost
what
like
is, no, see,
okay.
hypothetically at present what is the market size?
So what is the what size?
Market size.
Market size.
Yeah. And
So in the market, like if you want, then it's coming out to be like uh $50,000 and also actual human heart transplant, because
here,
it's not,
are,
yeah, it's
are
not
you
that easy because one person has to go off to get the heart right. It's not an easy thing. It's a very
Yeah,
disturbing
I think
topic to think about.
I think Sir's
Yeah.
question is not. So these numbers to us
Yeah.
don't look high at all. What you have here, they're actually very cheap compared to what people have to pay for
Yeah. Yeah.
actually getting heart transplants. So that's not the question. The
Yeah.
question is
Yeah.
just understanding your thought process behind. If you've thought through the scale of what you want
Yes,
to do.
yes. This is
That's how.
actually a very minimalistic topic, ma'am.
Yes, exactly. But this great effort, guys. This is awesome. Even to think of this idea, and as engineers to think about the biology of things,
Yes,
it's
ma'am.
commendable.
Yes, ma'am. Thank you, ma'am.
you see what the calculation you have done because until unless economic because you see you are ultimately your model will be for you'll be going for the business, right? Business. And in that, what is the market size and what is the costing and what is the economic justification that you are doing?
So your voice is not audible, sir.
Not audible?
Yeah, now it is, sir.
Okay, okay, okay. Right. So that economic justification unless it comes, right? Suppose tomorrow you ask me to invest.
Yeah.
Right? So, okay, definitely I will not look for what is your model. I will just think about my rate of return and your investment and what are your fixed and what are your variables, what are your outlay. So all those things should be there, right? Those things are missing here.
So if you want the payback period, then I can give you the payback period. Within a year, you can easily get back with the payback if you're going on
Have you
for
have you
a goal.
calculated have you calculated payback period?
So I can calculate it right now and give it to you because this is a random estimate that I have given about the 10 lakh that is written over there at the bottom. Rachel, can you go to the last?
NPV calculation also you have done?
Which, sir?
Net present value because if
No,
you're
sir,
going for
not.
payback period,
Yeah, payback period is done, sir. Payback period is easy, right? Because see, it's 14 lakh 69,000. The 10 lakh is just a random estimate that I'm giving you, because if we cost, like, if we give the model like for 2,000 per model, 10,000 into 2,000 is coming out to be 20
Okay,
lakhs. So
okay,
like within
okay,
a year,
okay, okay. Thank
payback.
you very much. Thank you
Yes, sir.
very much. Okay,
Thank, thanks.
I have heard you. I have just seen your presentation.
Okay, sir.
Got evaluated. Yeah, Maria Madam, if there is any question. Yeah.
Yes, ma'am. See my screen? Hello?
Yes.
Okay. So, good morning, sir. Good morning, ma'am. I'm Arpita Kar, and my teammates are Benir Falcao, Saurabh Bable, and Fazil Sheikh.
What is your team number?
Unfortunately, so
Team
sorry,
number? Team number?
team number four.
4. Okay. And
Yeah.
there is one request. Okay.
Yeah.
Whosoever is presenting, only switch on that mic because a lot of disturbance is coming. Okay. Rest all the mics should be on.
Okay, sir. Okay, sir. Okay. I just wanted to say something that Saurabh Bable right now is not present because he had some family emergency, so he had to go to his village. So let's start the presentation. So what is DocuCraft? DocuCraft basically it's a system which provides hard copy as well as soft copy of documents and certificates like living certificate, train concession, bona fide certificate, bus concession, then migration or transfer certificate after verifying the required data of the student from the centralized college database. So why we did this? Because to ease out the current process. The current process is very tedious. It requires a lot of paperwork, document verification, document submission, and it takes more than a week. So to eliminate all this process, we have created a system. The system consists of three subparts: online, offline, and courier. The online system provides the soft copy or basically the PDF version of documents and certificates. The offline system is a vending machine that actually prints the original hard copy of certificate with sign and stamp of principal and other authorities. The courier service, in this, the student can basically request for the original hard copy from the college. They have to pay the delivery charge and they have to give the address, and this way the college will deliver the document and certificate to the student. So let me just give you a gist of each and every system. The offline system, why we did this, as I said, that completing the current process is very time consuming as it requires a lot of paperwork. Students have to stay in line for 2 to 3 hours. They have to come to college every day just for one certificate or document. To eliminate this, we made a vending machine. LCD screen will be showing the whole project, the photo. From where they have to give their input, like maybe the currently we have used their roll number and OTP system. So it's two-factor authentication. Once they put their roll number, they will get a OTP number on their phone number. Then they have to give that, and then they can access whatever document they want. They have to choose the document, and it will get printed. In the online system, we have created a student portal through which they can basically download the PDF version of this document and certificate. Why we did this? Because during the pandemic situation, students were unable to come to college to get the certificate and documents. So in this way, by staying at home, they can get their documents and certificate, but yes, in PDF format. But in case the student want the original hard copy with the original sign and stamp, then they will go to the online system. The online system basically provides the original sign and stamp. Then in the student portal, basically we have delivery service. Once it is done from the college side, they'll print the certificate and they will courier it to the students. So in this way, student doesn't even have to come back to the college. Why we did this? Because after engineering or after any degree, most of the time students are going for masters or their job location is on other state or city. They are unable to come back to the college. For this, we have made the courier system. So, what is innovative in this project? This proposed system will provide both online and offline services, that is, both hard copy as well as PDF of documented certificates to the students, and they can retrieve this, like, of course, the documented certificates. Then it is advantageous for the students who stays close as well as far away from the college. It's good for students who are living at Pune or out of the country, and also for those who are living close to the college. They can come back to the college, take their certificate from the vending machine, go back home. And who are staying away, they can order it via courier service. This system also helps to save a lot of papers as well as time, which is wasted on taking approvals, then taking approval from the HOD or librarian, then paying dues and showing the receipt to the librarian. This is very time consuming. So we have tried to make it eco-friendly and time saving. So this is the whole project. This is basically the vending machine through which here is the printer. From here, the original hard copy will be printed, and this is the LCD. From here, the student will give the input, maybe their roll number or whatever authentication the college wants. So we can customize it according to each college. So this was a whole gist of the project. I will now hand it over to Benno Falco for the business model. Just 1 minute, I'll just
Thank you,
mute
Arpita.
myself.
So, firstly, I would like to wish all the women present here in the meet happy Women's Day. My name is Banhar Falca. I will be presenting the business model canvas for DocuCraft. So now, as we move ahead with the business aspect of our project, here is the business model canvas for DocuCraft. Starting with the key partners involved will be system integrators and independent software vendors, hardware maintenance and repair service providers, and the printer companies from whom we can source our printers. Now, for example, if a college has hired some independent software firms to develop the entire online system, we can partner with such independent software organizations who build and develop systems for educational institutions, which will surely help us in indirect sales of our product. Apart from this, metal sheet vendors are also important to make a metal structure of the vending system. Key activities to be performed will be installation and maintenance of document vending system, management and monitoring of document vending system, and R&D of document vending system and online portal. And lastly, customer service and support, which is utmost important for any business. Key resources required will be document vending system part vendors, printing and paper supplies, basic IT infrastructure, skilled development team and technical staff, and sales representatives. Now, some of the key points that will add value to our product are as follows: easy access to required important documents, time and cost efficiency for students and institutions, reduction in administrative workload and cost deployment of dynamic online portal for managing data remotely, real-time information on pending deals. From the above mentioned points, reduction in administrative workload means that the entire manual verification process and preparation of documents, which is currently done totally manually, will be completely eliminated. Instead, the system will take care of it. Moving on with the customer relationship can be handled by personalized support for educational institutions during the setup and implementation process, providing 24/7 online chat support for queries and documents and discounts on subscription renewal. Target customer segments will be obviously educational institutions, but we can also try to sell our products to government authorities, hospitals, and offices where frequent document disposals are necessary on daily basis. Channels to reach out to customers and to expand our customer base will be DocuCraft website, social media platforms, sales representatives, direct marketing, partnership with educational institutes and government offices. Now, coming to the overall cost structure, major expenditure lies in the following areas. First major expense would be document vending system and software development expenditure, followed by production expenses, production delivery costs, salaries and wages for sales and technical staff, and lastly, marketing and advertising expenditure. Revenue generation will be roughly through direct, indirect sales of document vending system, rental revenue, subscription-based access to online portal, and annual service revenue. Uh, Now, I would request Arpita to carry forward the presentation by explaining the cost sheet.
Sure. So this is the cost structure. Uh, so basically, right now the cost sheet is based on our prototype, not on the business level. So our total overall cost which went is about 15 to 16,000. But we'll be explaining everything what we needed and what we didn't. So the first thing is we bought a 7-inch touchscreen LCD, which was almost 5.5K. Then we bought a HP printer. Now this is a very normal printer. We used it for the prototype, but when we will be going for like a business level, for industry level, we'll be buying a good quality printer which could print basically actual certificates, those glossy paper certificates. And also the touchscreen LCD will be changed to a 10-inch LCD, which normally used in ticket counters, train, railway station ticket counters. So those LCDs are basically of 10,000, but we used a 7-inch right here for the prototype. Then we used a Raspberry Pi 4, which overall cost is around 10,000. Then Raspberry Pi charger, almost 700 rupees. Extension board, 400. Then this is like an overall cost of screw, nut, washer, stand. Then we had a SS handle. It almost took 220. And the MS structure fabrication, which you saw in the PPT, the blue machine, it took almost 4,000. Then the color coating of ivory color. We did this because since it's an MS fabric structure, so it might get rusted very soon. So that's why we did a color coating of ivory color. It took almost 500 rupees. And on top of that, we stick this blue acrylic sheet, which almost costed us for 1.1K. And top of that, we use this DocuCraft sticker logo of 200 rupees and other miscellaneous like white pages. It was of 100 rupees. Till now, we didn't bought any cartridge for the printer because whatever we have, it's full. Like it's going on right now. So just in case if we need a cartridge, so it would almost take like 1,000 rupees for color as well as black. So the overall cost is 25,585. But this Raspberry Pi 4, which we borrowed it from our department. Our ECS department had this. Previously, actually, we were using Raspberry Pi 3B Plus, and it was almost 5,000 rupees. But its performance was not like up to date. Like it wasn't quite good as per our project. So we decided to take a Raspberry Pi 4. But fortunately, we got to know that our department has a 4 model, and we borrowed it from the department. But if we have to buy it, it would almost cost us for 10K. So this is the whole cost sheet of our prototype. Now at an industry level, everything here will be changed. The LCD will be a bigger one. The printer will be of a very high quality printer. We'll be using a better version of Raspberry Pi, which has a better performance as well as better Wi-Fi module. Because our whole project works on the internet. Without internet, it will not work. Apart from that, we might be changing the MS structure. Instead of that, we can use a plastic structure, for example, which is at the ticket counter, like railway ticket counter. There is a plastic structure. Under that, there is a LCD controller and the printer. So we can also do that, or we can use an MS structure. It will be basically based on the college, what kind of structure do they want and where they want to install in the college premises. And this acrylic sheet logo, this all depends on the college whether they want it or not. We did this because we wanted it to look good. That's why we use this acrylic sheet and logo. Now it depends on the college. So everything is customizable. The basic cost will be based on this printer, this controller, and the LCD. Apart from that, all these are variable. So that's it from our side. So.
Hello.
Thank you. Go ahead, sir.
Okay. See, first thing is, okay, your concept is good and it's not new. Okay, even in Maharashtra also, for land records and all. Okay, these things are available. However, what you are trying. First thing is, I'm just trying to ask you whether what you are proposing, it will be a subscription-based model.
Subscription-based model.
Yeah.
We can keep both. We can keep subscription for those colleges who cannot afford the whole system, both the vending machine and the online portal. Or else we can, the college can of course buy it and they can do the maintenance by themselves, or they can give it on a contract basis to us.
Oh, okay. Okay. See, the thing is, suppose now there are a few more questions. Suppose if you are having one machine, right, and in that machine, suppose 4 colleges opt for, and you have kept it at some other locations, let's say Andheri, okay, not in the college, since it is based on interpret, right? Then what part in the beginning in your presentation it is written, but later on in the costing part or in the model, because at the back end from the software or the data that will be faced in, okay, and the authentication of those data, and as you said, the OTP based system will verify, right? So what are the channels? What are the channels, and what are the levels that you have to, verify? Thereafter, only once it is approved, then only it will come to the machine and one can take the printout. Okay, that part is
Okay.
completely missing. Yeah.
Yeah, sure. Okay, so I'll just go and present it here. So you have a doubt like whether if this vending machine is installed out of the college and multiple students from multiple colleges are taking print from this vending machine, then that could be a problem. You're asking this, am I right,
No,
sir?
no. That could be a problem. That problem part I am elaborating. The thing is,
Okay.
authorization of the student, authorization of the document, okay, that is to be approved by the authority, right?
Yes, yes.
Because you are just the service provider, right? And
Yes,
once
sir.
they authorize, they are responsible for that authorization. You cannot take the responsibility of that. I'm talking about that.
Okay, so can I demonstrate my project? I think it will be more better to explain it rather than just say. Is it okay, sir?
I think we'll run out of time if we do that.
Okay, okay.
The,
Okay, no problem.
the main point, I'll echo what Das sir is saying. The one thing that did come to mind definitely was the security aspect of things and authorization. So if you get things notarized, you get affidavit signed. This is at the same level of magnitude in terms of what you're thinking. So just for future sake, I guess you could think through the security aspect of things.
Yes, ma'am. So basically, we have a teachers portal. I didn't mention that, but we have three parts. First is the vending machine. Second, the student portal, and third, the teachers portal. Now, just for example, I'm taking for living certificate. Now, living certificate is given for after you complete all your criteria. Basically, like you have completed your library dues, then you have paid all your 4 years of fees, then you have cleared all your exams, done your all hostel means. Once everything is cleared, then only you will get your living certificate. It's not. Same process is done by our vending machine.
I think question is more the question is not about when it will be issued. The question is how will you prevent counterfeit? If I know what the media straightforward, you use glossy paper or any kind of ink, I could print it out myself. So how will you prevent something you
Then
think about
we
your next way?
have like tons of we can use RFID. Student have ID card. In ID card they have their barcode. We can use RFID card for student authentication. Student have their own email ID and password, which is given by the college. They can also use that. So there are tons of way to authenticate a student. Now it depends on the college what kind of authentication do they want to use for their students. For example, for right now for demo purpose we used OTP system.
That's okay. I was talking about authentication of the document itself, but that's totally fine. I think a great job. Happy with this presentation and
Okay.
very very good.
Maria,
Really good.
okay, so can you just give me 1 minute? I can explain the authentication of the document. We have also added a QR code in the documents. Just like in Aadhaar card, we have a green tick and a barcode. barcode, which authenticates that yes, this is a document, this is the Aadhaar card of this ABC person. Similarly, we have also used a barcode in our certificate and documents. Once you scan it, you get all the information regarding that student that is from this college branch here.
Arpita.
Yes, sir.
Yeah, I heard you. Okay, and I can understand your motto. Okay, you are in the right direction, but then there are so many queries, and we don't have that much of time. Okay.
Okay.
So what I would suggest is, okay, later on you can meet me. Okay.
Yeah, sure.
Okay, later on you can meet me, and I'll just explain you a few more things. Right. Okay. Thank you very much.
Sure. Thank you, sir. Thank you, ma'am.
Thank you, everyone.
Thank you. Great job.
Yeah, sure. We'll go ahead and present. Yeah, of course. We're going to be doing this. Am I visible and audible?
Yes.
All right, awesome. So this is our team. We are going to be making a BMS for electronic vehicles. So my team comprises of me, Sherwin D'Souza, Bryson Fernandez, Shibu Matthew, and Sparsh Bindro. And our guide for us is Dr. Sapna Prabhu. Currently, Sparsh Bindro has not been available during the meet, so we can go ahead and continue with that. So let's look at a bit of an agenda for today. So we have a previous designs which we're going to be showing you, new changes, implementation, and what's need to be done. So basically what our problem statement is, if you see any type of electric vehicles or any type of electric commodity or service or whatever you may say, or any commercial vehicle, it requires battery management, and of course it requires batteries so as to manage its power consumption and power usage. So for that, there is a particular device which is called a battery management system, or a BMS. That BMS usually takes in all the values from the battery, may it be voltage, may it be temperature, may it be current, may it be how much it's sucking in, what is the amount of battery left in the batteries itself, that all, and it's going to be managing the entire criteria so as to make a healthy operation of the battery itself, so as to not, as you can say, blow up the batteries. So here, what our problem statement is, we are going to be reducing the overall cost for a commercial BMS. We are going to be making it a centralized versus slave and master code designs. We're going to be making it scalable and also having an IoT implementation to it. Let me just quickly gloss over what the statement was. So this was a previous design where it was too messy and all this, and there was really no path for scalability. But now we're going to be having some attempts to solve this issue. So that we try to increase. This was an initial complex solutions. So because of that, we went ahead and made some new changes and such, and brought down the complexity way less. Whereas you can see we even designed PCBs and such to make the device much more understandable by the common person. And how it can be changed and how it can all for the diagrams for the implementation. That's for the implementation of our DMS modules. So this is basically like, you can say, a small little demonstration of this. If required, we can play this videos, but I think we'll just gloss over them. So it's basically like a BMS management system. As you can see, there's a battery on the right hand side, and this is being managed by output monitor as such, where you can see the particular values given to you of the battery itself. So now just a simple timeline as to how we're going to be doing. So we're going to be creating the final designs and also manufacturing for that. Then we're going to be checking compatibility with each other and scalability is possible or not, and then final integration with the interface. Lastly, here's some budget comparisons. So we've been comparing our BMS to the commercial BMSs which are there available in the market. So we, as you can see, that EMS BMSs are available near 2 lakhs or somewhere 2.2 lakhs. Orion BMSs are somewhere around 1.9 lakhs, and our custom BMS is coming around 41,600. The detailed budget can be explained to you by my colleague Bryson Fernandez. He's going to be sharing his thoughts. Okay.
Hello, good afternoon, Banu. So, as you were aware that the Orion BMS2, we did a comparison between the Orion BMS2 and EMIS. These are the most reputed or BMS manufacturers in the world today, and both of these are imported from US. If you ever choose to convert your regular vehicle into an EV vehicle, you would have to use one of these BMS, and these can monitor only up to 120 cells in series. Whereas the benefit in our custom BMS is that you can scale it as per your battery requirement. A lot of the commercial vehicles have different battery packs based on their energy requirement. Their designs are different. So one BMS is not going to fit for all, and that is where we come into the picture. With our custom BMS design, you can monitor n number of cells by just adding the slave codes in n number of series. So as you can see, this is a cost sheet for the total BMS. So one slave board costs us around 33,000 to make. In this slave board, you can monitor up to 10 cells in series and also monitor the temperature of the cell. A safety provision will be made where if the temperature of the battery pack exceeds, there'll be a shut-off system that will cut off supply from the main battery pack to the entire tractor system. So this is a safety enabled in our BMS system. And along with that, we have a master board. So the master board is going to be the main communication with this label. And what it does is it will what occurs, it will cut off supply from the main battery. Also, then that will state this state will the entire BMS system in Orion is
Great job in all the analysis. That's just tonight. So tonight for me, today for you folks. Yeah, so great job on that as well. Yeah, I think she slightly touched on the safety aspect of things. That would be the main concern. That's I think cost wise, you guys have nailed it pretty much. But yeah, just safety wise, maybe more efforts and costing may change on that front. Who you mentioned electric vehicles being your market. Who else is your target market here?
So mainly our ideal customer are those who want to switch or who want to convert their regular vehicles into an electric kit. So if you see, a lot of startup companies are beginning to make conversion kits at this point, and we may want to tie up with them with our BMS system. To integrate a BMS system is very difficult for a regular engineer. So we want to catch hold on this niche market and help those who are already converting their kits. Later on, we can target with commercial vehicles. We can those who are well established like Tata, Mahindra, and try and incorporate our BMS system with these guys. But mainly those who are ideal customer for now are those who want to convert their regular petrol and diesel vehicles into an electric vehicle. So it is easier for them.
So do you know what the market is for that? Like, what's the demand?
We haven't removed the total available market as of now.
Okay, yeah, just wanted to understand why you would go the end customer route versus going the enterprise route, considering the market in India for electric vehicles is just starting up. So it's not, in my opinion, at least
Yes,
I haven't done any
yes.
research on this, but intuitively it could sound like you would
Yes, ma'am.
want to go
I
the
understand your
enterprise route,
concern,
but
and one reason is so companies like Mahindra and Tata have a specific design in mind, right? They design their battery pack has for one current vehicle, and their BMS system will be designed to monitor that certain amount of number of cells in series. Whereas if I choose to convert a vehicle from a regular diesel petrol vehicle to an electric, I have the flexibility to increase the capacity or reduce the capacity depending on my requirement. If I want a lighter weight vehicle, if I want a vehicle that can give me much more range, I have that flexibility. So my BMS system allows me that flexibility in order to scale it up. So based on the number of cells I have, I can increase the number of slate. Whereas if I would tie up with companies like Mahindra or Tata, I wouldn't have that flexibility because they already have a fixed design in mind.
Okay, thank you. That's it from my side. That's sir.
Thank you.
So regarding this market capitalization strategy, okay, most of the things I have seen that nobody is talking about that. Right? So what do you have thought of in case if you are going for?
If we go ahead, firstly, we would want to do a total available market, a TAM SOM. Also, along with that, we would want to do a pestle analysis or a SWOT analysis for the entire business plan and a DC evaluation for the entire thing. As of now, we haven't completed this, but this is what we have in mind for the next round. So that would include a budget allocation for the entire project. Then we would establish based on India's long-term growth, that is around 6.5%. We would then project the future revenues of the project, and based on that, we would do a DCF analysis to show the investors the net present value of their investment. So this is what we have in mind for the next round.
Okay, thank you.
Thank you, sir.
Thank you so much, sir. Thank you so much, ma'am.
Hello, sir. Am I audible?
Yes, Ishan, you can start
So
the
this is
sentence.
team automated solar panel cleaning system. So we'll be not currently presenting. Tanisha, you can go on with the
Yes, yes.
production.
Okay, so very good morning to the panelists and my dear friends. So our topic for today is automated solar panel cleaning system, and we have started this project under the guidance of Dr. Deepak Goyal. He's been our guide and helped us with our project. So our team members include Zishan, Tanisha, that's me, and Omkar Patil. Problem statement. So our problem statement includes that it is majorly regarding solar panels and their cleaning system. So solar photovoltaic modules are generally employed in dust environments. So in a lot of places where solar panels are mounted, there's a lot of dust in the environment. There are other factors hampering the efficiency of the solar panel, and the dust gets accumulated on the front surface of the module and it renders it ineffective. So it blocks the sunlight on it, and the main principle of solar panels is it works on the sunlight falling on it. So if there is a hindrance on the sunlight falling on it, it won't be that efficient. So it reduces the power generation capacity of the module, and the power output reduces as much as 50% if the module is not cleaned for a month. This has been we have found out by a few research papers and our own experiments. In order to regularly clean the dust, an automatic cleaning system has been designed which senses the reduced power and also cleans the module automatically. So I think one of the main objectives regarding this project was that while cleaning the module, there's a lot of since it's at a height, it's elevated on the system is elevated. What happens is there's a risk of life if people go onto such heights and clean the module, and it's inconvenient basically to anybody trying to clean the module. So an automated system would help in eliminating the third person or a person going up and cleaning the module. In terms of daily energy generation, the presented automatic cleaning system provides 30% more energy output when compared to the dust accumulated photovoltaic module. Moving on to the objectives. Our objectives are effectively the first objective of
Tanisha,
our...
I will be explaining.
Okay, sure.
Hello, I am audible.
Yeah.
Okay, so I will be talking of the objectives of our project. So one of our objectives is increasing the efficiency of the solar panel. So whenever the efficiency decreases, our cleaning system will start and it will clean the solar panel properly, which will eventually increase the efficiency of the solar panel. Then one more objective is with we will be implementing it with the help of IoT. So with the help of IoT, we will be remotely monitoring it, the condition of the solar panel, and then we will also with the help of IoT schedule the starting of the cleaning system. So whenever the efficiency decreases, the solar panel will start and clean the solar panel cleaning system will start and clean the solar panel, which will bring the bank so bring back the solar panel to its normal condition. Then one more objective is, as it is automated, no manual cleaning is required by human. So this will reduce the cost, and also it will increase the efficiency of the solar panel. The next slide Jishan will explain.
So a very good morning to one and all. So this is our proposed system. So like we'll be deploying a current and a voltage sensor that will sense the solar panel voltage, and as the solar panel voltage uh, goes down to below a threshold, our panel activates itself. So we have devised a solar panel using a scissor lift mechanism, and that uh, and we are driving the solar panel using a linear guide and DC motors, and there is a sprinkler system attached to it. Ultrasonic sensors are used for the edge detection as the solar panel is automated, and we'll be using a ESP32 development board that has Wi-Fi capabilities for pushing data to Firebase and then displaying data and on our web apps or some things big IoT cloud infrastructures. So this is the SolidWorks model that we have created. So as we were researching about many existing systems, we found out that all the system works directly on the panel, like they move on the panel itself. So as time goes by, the panel develops micro cracks as the solar panel glides on the solar panel itself. So we are currently eliminating that problem. Just we are guiding on the edge itself, and for the cleaning purpose we are using a scissor lift mechanism that will be actuated using a stepper motor and a lead screw mechanism that will uh, move the brush back and forth using the lead screw, and the uh, ultrasonic sensor will be used for edge detection and all that. And this is the final schematic of a automated solar panel cleaning system. So this was our presentation, and now the cost of our system. So we'll be needing. It will be like we have reviewed the other system, and we have come to a point that this is the final cost, like the final product, that output that we'll be making. So this is the got it around 11,500. So we are using pipes and valve connectors, aluminum sections for the structure itself, sheets, aluminum sheets for the mounting of the stepper motors and the motor itself. We are using two pair of wheel, and the model will be made using welding, aluminum welding techniques. Linear guide will be used for the supports rather than the wheels, and nylon brushes will be used for cleaning. Stepper motor will be used for the scissor lift mechanism, and the main microcontroller board we are using is ESP32, and we are using the T658 motor driver as our motors require more torque and they have higher current consumption. So we came out with a cheap solution that has this motor driver has a good current rating, and we are using an A4988 Shepherd driver, ultrasonic sensor for edge detection, relay module to control the solenoid valve, INA226 voltage sensor for sensing the voltage and current. We'll be displaying these values on our OLED display as well as the web apps and ThinkSpeak and IoT cloud infrastructure. Buck converter will be using to step down the voltage of the solar panel from 24 volts to 12 volts, as our system is currently operating at 12 volts. And rally limits and green pin connectors are the connectors for interfacing the driver with the motors itself, wires, and 12-volt planetary gear DC motors and the lead screw. So this is the total cost that we have come up. It's around 11,503. And this will be the business model canvas, and it will be explained by Omkar.
Hello. So the business model canvas. So our key partners would be government solar panels. So the solar panels of the government, with the help of our cleaning system, can maintain the efficiency of the panel plants. Team Robocon CRC, which is the team of our own college, with the help of them, we can make our cleaning system more better and efficient. Key activities. So key activities of our solar panel cleaning system is to clean the solar panels properly, and with the help of, after cleaning, the efficiency of the solar panel should increase. And in this we are also remotely controlling, we will be monitoring and also scheduling the cleaning of the panel. The key resources here which we'll be using is water. To clean the solar panel, we will be requiring water. Then the power supply should be given to the solar panel cleaning system, and also to make the solar panel cleaning system or to maintain it, we will require electronic components. The cost structure. So for research and development, we will the cost will be required. Then for also making the solar panel cleaning system, and also afterwards for the maintaining of the solar panel cleaning system also, there will it will incur some cost. The next part, Tanisha will explain.
Yes, so thank you, Zishan and Omkar. Value propositions. So our key objectives behind our value propositions were that we wanted to eliminate the human element, considering that there's a risk of life. Plus, we wanted to eliminate the cost it would take for a human to work. Not required to clean a solar panel by human manually, eliminating the human or the manual element, increasing the efficiency of the solar panel generation. Sometimes humans cannot clean it to that context, and they cannot do the job that well as a solar panel do, considering it would have brushes and water. Customer relations would have personal assistants. Customer segments include government entities, commercial customers, and residential customers. People having uh, solar panels mounted on schools or workplaces, offices, or government buildings would be one of our major customer segments. Also, people that have planted or mounted solar panels for their own personal use, they would also be a part of our customer base. Our channels would, our promotion or sales channels would be internet sales, that is e-commerce or e-business, and sales network using online marketing or online advertising. Revenue streams include asset sales, that is each photovoltaic module or cleaning system sold, we would get the sales on that, the profits on that. Maintenance charge, so each module or each cleaning system would require maintenance, so those charges will be different.
So, right. Thank you. This will be the end of our presentation for today.
Yes, that will be all from our side.
What is the maximum area that it can cover?
So the maximum area depends on, like, it can cover, like, the solar panel. It doesn't have a maximum limit. Like the linear guides that are mounting on it, increasing that support, it can cover a huge panel array.
So when you are saying linear guide is supported, that's what I am saying. So if linear guide is not there in the solar panel that you are fixed, okay. So without is whatever area I'm talking. Okay, if linear guide is not there, then it will not be possible, right?
Yeah, yeah.
Then it will not be possible because you just your friend was talked about the robocall taking help of them. Okay, so I was just thinking that whether it can handle any sound.
So currently, sir, no, but we are working on a different, like, I was thinking of a different idea that will be like a clamping mechanism that will clamp the panel from the three sides. Since the panel is tilted at a 45-degree angle, we can still use like 3-degree clamping of wheels that can maneuver the bot over the panel itself.
Because you see, normally what happens when it is whenever you see wherever the solar power generation is there, it is in hectares.
Sir, I'm not able to hear you clearly.
Now, wherever solar panel setup is there, okay,
Yeah.
they are generating. So the solar panel is laid down in hectares of land. That's why I asked you this question.
Solar panel voltage will be directly supplied to the model.
Just talking about the area only.
Sir, I'm not able to get the question and I'm not able to clearly hear your voice.
Regarding the costing part,
Sir, you're not clearly audible. We cannot hear what you're
you're not,
saying.
yeah, am I audible now?
Yes,
Yeah,
yes.
yeah.
However, the costing part,
Okay.
audible.
Yeah, yeah, sure.
Okay. However, the costing part,
Yes.
uh,
If my screen is
how,
getting
how, how much it is?
it's
11,500.
11,500.
So how do you justify in terms of the economics?
So the previous panel, that previous solar panel heating system that we researched about and we concluded were around 25,000, 40,000, and the prices is going up. So this is a simple system. Like since I have past experience working on these machines, robots and all, so I came up. So I researched about the components and all, and these were the least costly things, like least costing materials that can be used effectively for our panel itself.
Okay. A few questions. You mentioned this would be more cost effective compared to using manual labor, and this may sound like a very basic question, but labor is is cheap in reality of the situations. Have you done any cost analysis compared to how often would you need to change brushes or refill water in your equipment versus actually having humans going in and cleaning?
So
Ma'am, I
like
would like to answer this question.
yeah, go
Yes.
ahead, Tanuj.
Yes, okay. So, according to our research, ma'am, the nylon brushes that we'll be using are quite sturdy and we can use them for a period of 8 to 10 months without changing them. As far as water that you mentioned, we are using a water recycling method where we'll be using the water and it will be connected to a refilling pump that will be on the base of the ground floor of the building, and the water that we'll be using will be recycled, so we wouldn't be using any external water source. We'll be purifying the same water and using it to clean it, and there wouldn't be excess water. In fact, we were thinking of implementing a system where we're using rainwater harvesting and using the same water in cleaning the brushes and the system. And considering the fact that if we consider that a human is cleaning them manually, we'd have to pay that person for every say 2 to 3 weeks when they'll be coming and cleaning the panel, and that would be a little more costlier for us, because here we are not paying for extra water or changing the brushes. So the system maintenance will be happening every 8 to 10 months, and a person coming and cleaning, we'll be having to pay them every, say, 2 to 3 weeks as and when the panel will be cleaned.
So the main thing was the cost analysis was done on the our college panel, solar panel itself. So the panels above the Samvad Hall are not like reachable for with manually. So we talked with the guide boy sir. So he suggested us for the automated
Yeah,
panel.
that makes complete sense. Yeah, I just wanted to make sure this was thought through. Okay, yeah, I have no further questions. Thank you.
Okay, just a tip to you. Okay, last week, okay, on the solar panel, one scientist has come up with some solution regarding this cleaning, okay, and the efficiency of the solar panel. Just try to find out the news, okay. That may be a challenge for you. Okay, it's just a tip.
Okay.
Last week only, okay.
Yeah. Sure, sir. Sure. So we'll be looking into that.
Yes, so we'll do that. Thank you so much for your time, judges.
Okay, thank you.
Yeah, ma'am, are we audible? Hello, ma'am. Am I audible? No. Hello. आवाज आ रही है मेरी?
देवेश, आवाज आ रही है.
Yes, ma'am. 1 minute. Good day, everyone present here today. We are the students of Father Consequer Rodriguez College of Engineering, Padra, pursuing B Mechanical Engineering. The following are the team members in this mechanical project. I, Nivesh Sharma, Brenda Fernandez, Atharva Belnekar, and Prachit Pereira. Today we showcase to you a new inquisitive project, which is the need of the hour. Our project, Amrutam, that is atmospheric water generator. As it is said by Albert Science Georgi, water is life, matter, matrix, and mother, which is a medium, as there is no life without water. With G20 presidency in India's hand, which is the main aim is to provide a global change for all to give and engage an inclusive environment. Water is a necessary component. Thus, it is our aim to create a project which includes everyone and gives a social solution to overcome the water scarcity. Water is a necessary component to our lives, which is hindered from time to time due to various parameters using technologies. We have used certain technologies to produce potable water from surrounding air. This product is in the view of creating atmospheric water generators range from house-based units that can produce 1 to 20 liters of water to commercial sale of 1,000 to 10,000 liters per day. Water production rates are highly dependent, due to which upon the air temperature and amount of vapor and humidity in the air. Helps in the feasibility of using these systems to help in the augment of nation's drinking water water resources. As we look forward with the basic idea of local to vocal, we have implemented projects in the past as well, which have implemented through local ideas. This study presents a brief overview about the design, benefits, and impact of atmospheric water generator. So, what is the accomplishment that we are looking about? It is to overall oneself distill water benefactory to serve society in the weaker sections like rural and social urban areas. So the first thing that comes in mind in our minds, what is atmospheric water generation? So atmospheric water generation is the process of generating water from the air using atmospheric water
You are not audible now. The mic is muted. You are not audible. Hello.
Hello. Yes, sir. Yes, sir. You are joining.
Yeah, yeah.
Hello.
Yeah, now it's coming.
Am I audible now, sir?
Yeah, yeah.
Yeah, sorry, there are some network issues. Apologies for that. So this study presents a brief overview about the design, benefits, and impact of atmospheric water generator. So as I was saying before getting disconnected, that this is also known as hydro panel or hydro project, which is a device that attracts water from the air, from the ambient air, producing potable water, including during condensation, cooling the air below its dew point, exposing the air in its condensation form. This cooling the air below its dew point, exposing the air to discadence or pressurizing the air. AWGs are useful where potable water is difficult to obtain because water is always present in ambient air. In the current global scenario, content of distilled consumable water is receded, to which daily life has been hampered. Atmospheric water generation thus acts as a solution to a worldwide problem. So the basic functionality of motion in atmospheric water generator is to produce water which contains at least a little water. On hot days, like when the air is thick and uncomfortable because it's saturated with moisture, water generation are also known as water markers, which harvest water suspended in humid air. Atmospheric water generation also extracts water from the surrounding air and filters to remove particulates and bacteria. The resulting water is clean and free of chemicals, which was one of the priorities in our project to provide clean, clear, and distilled water. So the resulting water can be provided in scarce and polluted water regions. So atmospheric water generation thus is a reliable source of clean and safe for water distribution facility. Electricity and fossil fuels are the problems that we face in our day-to-day lives. What atmospheric water generation can be proved helpful by generation of water through solar power energies and renewable energy purposes. As we trip down to memory lane, which provides various methods that had already been applied, which shows the traditional and other methods, as you can see in the PPT below. As you can see that what atmospheric water generation had already been started in the past in local areas with traditional and modern techniques have been infused to give the water see. As you can see the further examples, we have employed this strategy to invoke the slogan local to vocal to make it global. So as we trip down to this history, we showcase that the local practices were procured water just to provide water and enhance better with logical ideas. So as we move forward, we have already determined what is the calculative analysis of getting water, because at the end we have to determine the water analysis. So we have determined the use of Peltier. So what is Peltier? So the Peltier had different categories which we use with different mechanisms. So Peltier is basically a device which has heating as well as cooling system, which is just a panel on one side heating takes place as well as one side cooling takes place. We are taking the advantage of cooling in Peltier, which with the use of radiators, so that condensation happens and we get the use of water. With different systems in Peltier, like simple Peltier, cluster Peltier, we have tried in the ways of creation of our project. As we can see in the prototype, as we have shown on the right side, with the help of our teachers and with the help of our teammates, we were able to use that single Peltier with radiator provides a better efficiency. So we furthered our business with two types. One, as you can see in the PPT, the bottle representation of our project.
which we understand that in order to widen our business plan, we would be producing two types. One in which Peltier exists in the bottle, as well as two, the other one in which Peltier is attached on a bottle, so that we'll be widening our consumer base. So as you can see, the Peltier is in parallel phases, due to which condensation happens itself in the bottle, and you can procure yourself in the water. So the calculative analysis was done, in which you can see that the heat transfer, we actually assume that one Peltier with 75% humidity in one room of 140 cubic centimeter with temperature varying around 25 to 30 can produce approximately 3 liters and having a heat transfer of 86.28 watts. So the future plan and the conclusion is that we are determining something that is for providing clear and secure water. So the prototype and the BMES is as follows. BMC, sorry, Business Model Canvas. So the main aim when we are proposing something which is evidently like how we explain ourselves in Shark Tank, we are trying to showcase everything with proper steps. So our project, we have classified the BMC as follows. So the key partners when we try to establish is that the key partners are obviously going to be the government, because we are trying to reach the rural as well as the urban regions with the help of water purifying companies, which can be a beneficiary factors in healthcare centers. During the COVID situation, we actually went forward with oxygen concentrator in various hospitals. So we also understood that there was a need for water availability at that section as well. So we decided that this semester we'll engage with water, we'll embrace it, and we'll exchange, enhance it to give atmospheric water generator. So our valuable propositions was to create portable, lightweight, which is economical, which is eco-friendly, providing renewable energies, which is efficient. That efficiency is the key. So the key activities that would be about the main maintenance point of view is about treatment, regulations, and conservation of water. So the as we are producing a market for this product. So the main thing is what is the customer view? What who will be taking it? So a basic point of view was about trekkers who are traveling, who don't have point to refill their water. So this is an advantage for them as well. We go to customer relationship. How do we engage with the customer as well as the businessman? That we are giveaways, we're conducting trips, we're conducting drives that will engage the customer and it will aware about what is going to happen. Social media is an advantage in this generation where we can connect with another part of world. So through campsites, trip exhibitions, expos, and various types of things, we can create awareness about this project. Research and product development and maintenance of manufacturing plant will be in the part of the cost structure as well as the revenue streams are going to be with through customers' point of view, their opinion, their understanding, and their undertaking, as well as their meaningful explanation about our project. Customers are important part in a business. That's what we are taking as a revenue stream. The live stalls and user referrals are thus important. So thus we will be now showcasing you the costing. So we have jot down some of the important things like the equipments in our atmospheric water generator. So this is regarding this is regarding the consumer components that we have from about the water peltier, radiator pump, a pump converger, temperature, and various other things are established in this project that we are current focusing. We are actually creating some iterations in the project as well. As you can see, we will actually we should like take a moment to thank our guidance sir, Saurav sir, TSS Sudhakar sir, and our mechanical department faculty for being helpful and guiding us and encouraging us to give their thoughts and solutions, opinions to create a project for global impact. Thank you.
So have you really developed a model that is working?
Yes, sir. We actually during our stage one performance, we had created a prototype. I think we can show the photo of it if we have.
So
Yes, we had actually.
Yes, sir, we are showing it to you now. This is, you can see on the right side, we had already created a prototype which is having Peltier in that. We actually, this was a rough prototype just to showcase that water is happening, condensation is taking place. So you can.
No, I cannot see anything.
So you
Anything
can't
is
see.
there? No, I can just see the photograph. That's all. Okay. But it does not explain your model, what the objective you are just trying to achieve, right?
I'm sorry, sir, I can't hear you, sir. No.
Yeah, am I audible now?
Yes, sir, you are audible.
No, what I'm saying is I cannot see the condensation.
Sir, yes, sir, we'll show you the
Okay,
video.
we'll show the video.
I can just see some circuit that you are just showing.
Okay, sir. Okay. Actually, we didn't thought that we had time for the video, but we'll be showing you the video now. Actually, condensation did happen. I think a member has taken a video about it. It will take little time to show you.
While you're pulling that up, there are a bunch of companies that are doing atmospheric water generation. Have you compared
Yes, yes,
yourself with
exactly.
them?
Thank you for the question. Actually, I was going to mention about this earlier, but I thought it might not be happening because of the time factor. But actually, when we were researching, we came across 8 specific companies which are worldwide, and I think one is in India. So we were doing some cost benefit analysis. It is now they're doing in what is known as mass production. They're doing commercial scale. They are not doing consumer. So we are trying to create something that is on day-to-day person. Like a person is going to office, he needs water. He can't go to the and he's traveling by train. He won't expect him to take a time to go to the purify. For that person, we are creating this project. So this is something new rather than that company. They are creating for some big factories. So the cost analysis for them was in respect to lakhs. We are trying to jot down and create something efficient.
Can you remind me how much electricity in terms of or energy in terms of watts it was taking to generate 2 to 3 liters? You mentioned that.
Yes, yes, we'll show you the calculation.
And if you have the video in the meanwhile, you can of course share first.
Yeah. We are sharing that. Actually, net issue is happening over here.
Okay, I think you are not having it present. Okay, we will proceed with the next thing.
Sir, we are showing the video. I think we are in the library. And net का issue हो रहा है sir.
No, but the rest of the things I can see.
Sir,
No? Your
that is in
presentation I can
different
see.
laptops, sir. That's the issue. We are transferring from phone to laptop. Actually, sorry, sir. 1 minute, I think. Sir, can you see the video now? We are just presenting it to you now. You can see, I think. See, yeah. So this was the video that we had taken. This was just a brief video we had taken. We were in quite.
That is done by your team. Yes, sir. That is done by your team?
Yes, sir. It's done by our team.
Okay. Okay, we'll see. Next.
Just one quick comment. I know you were talking about making this a B2C sort of model. You may want to consider economies of scale as you go forward. It's a great idea. So you may want to think about maintenance cost of each of those if you were to go B2C in this case. But yeah, great job. Thank you.
All right, ma'am. Thank you. We'll consider it. Thank you for your time.
Yes.
Yes,
Yes,
ma'am.
ma'am. Yes, ma'am.
Shavni?
Yeah, 1 minute.
Shavni, are you able to present? Ma'am, 1 second. I think she's facing some network issue. If she isn't able to present, I will present.
Kevin, I think you should start with the presentation. So present the screen. Yeah, ma'am, just a second. There's a network issue. We'll start the presentation. Just a minute.
Is my screen visible? Hello?
Yes.
Yes.
Okay, Shami, go ahead.
Good afternoon to one and all present here. My name is Shravani Tari, and my team members are Kelvin, Darren, and Neha Mane. Currently, Neha Mane is not present in this meet, and our project is decoy deploying drone, and we are under the guidance of Professor Saurabh sir. Hello.
Yeah, go ahead.
So, as we all know, most of the Indian weapons are brought from foreign nations. So, in order to support Atmanirbhar Bharat, we came up with the idea of making decoy deploying drone. So, basically, drone is a type of unnamed aerial vehicle, which is an aircraft without a human pilot, crew, or passenger. And decoy is a simple flying object whose purpose is to just fly straight in a fixed altitude. This drone is specially designed for military purpose to locate enemy's man paths, which are equipped with laser trackers. So instead of using multiple small drones or a single drone, we will be using balloon or something like that for the decoy purpose. So the advantage of using this drone is to reduce the risks of human lives or the loss of an armies, and also to cut the cost of decoys. The next
Do
slide
you want me to
will
change the
be
slides
taken
now?
by Kevin. Yes, yes.
So I will directly jump onto the design of the quadcopters. But before that, I think you might be having a doubt on what a decoy is. So I hope that right next to you might be having an object. It can be a bottle, it can be a pencil box or anything. But to explain a decoy, every object has a signature that can be measured. So, if, for example, your water bottle must be having an heat signature. It must be having some temperature, which can be detected by a thermal camera. So, decoy's purpose is to simulate that signature and present it in front of the measuring device. So, for example, so decoys are used to actually defend from the enemy missiles. So, whenever an enemy launches a missile, missile has a measuring instrument called seeker. So it tracks on based on the heat temperature or heat signature of the object that it has to hit. So a decoy is like generates a fake signature of that target. For example, in modern fighter jets, the engine generates hot air when flying. So to create a decoy of that, flares are launched from the back of the fighter aircraft, so that the enemy missile will be confused on what target to hit. So this is what a decoy is. So for that, we have designed a system which will launch, which is actually a quadcopter which will launch a decoy. So this is the quadcopter design here. So this is a very ingenious design. So as you can see, for the arms, it resembles very highly to a crane structure. You might have seen the cranes building the cranes in construction sites. They are this kind of beams that increase their strength to weight ratio. So using the same design, we have made the arms for this drone, so to get high strength to weight ratio. This is the circuit diagram. At the end, you might be seeing left side, you might be seeing three windings. Those are the brushless motors. Then in the middle, the big black circuit board, that is the flight controller for the drone. And middle of both the windings and the flight controller circuit board, there is an ESC. This circuit is used for controlling the speed of the motors. And finally, at the right top corner, there is the transmitter receiver circuit. These are the circuitry required for making a drone. Uh, so,
I'll be proceeding with the business model canvas. So is my screen visible now?
Yes, it's visible.
Okay. So this is a business model canvas. So our key partners are Mavericks team and Vayu team. We have actually asked for their guidance for many times, and we have shared many resources like charging stations for our batteries, and also providing us with some materials. Key activities that we need to do so that our product stands out. Construction of custom flight controllers. So we need custom flight controllers since this is actually a military based project. So actually this is a very sensitive sector, so we can't just use any already market available components. We have to use custom components that are not available online or anywhere to maintain the secrecy. Incorporation of indigenous components. So as you can see from around you, the indigenous defense market of India is growing very highly, and under the Modi government, one second. Under the Modi government, the indigenous equipments are being pushed forward for use in the military sector. So the more we use indigenous components in our system, the more it is likely for our system to be attractive to our armed forces. Then values that are project presence. So the main value for our customers that it proposes is that security of pilot. So the amount of life that this system can save is very high. Since you must have seen in the Ukraine war, Ukraine Russia war, the Ukraine got the Stinger missiles from the America, which shot down many of the uh, Ru- Russian helicopters and fighter jets. So from there we got the inspiration that this is a very uh, very big problem that Russian pilots are losing life there, because of the simple, cost-effective missiles. So to save their life, we are using we are making a project on decoy deploying systems. Then security of combat systems. So the loss of life of pilot is very saddening, yes, but in war systems that defend your country like fighter jets, helicopters are also important for the contribution of winning the war. Then saturation of enemy defense. So the saturation term is used to explain the explain in saturation term is used in military to explain that the uh, enemy air defenses are confused. And surveying of the battlefield. You can survey the battle. Excuse me, can you please not make noise? Please don't make noise, please. I'm making it. Surveying of battlefield. So you can survey the battlefield depending with the help of this technology. Then customer relationship. So the Indian so to maintain a good relationship with customer, the uh, armed forces of India always like to uh, be provided with the service and logistics of the systems they buy. So they just don't buy the systems alone, they also buy the logistics and all the other key components required for the operation of the system, and constant training of the individuals that will operate the system. Then channels. So the channels are government channel. Defense Ministry regulates and authorizes all these projects. So we have to always be in touch with them, or we can be in collaboration with private industries to to work with armed forces in this. Our customers are Indian Air Force, Indian Navy, Indian Army, and Indian Coast Guard. So further going, key resources are carbon fiber and custom brushless motor, because this drone will most probably be used in Ladakh, and Ladakh is a very high altitude region. So henceforth, we need a special motors, brushless motors, so that they can provide high lift and give high performance. And cost structures, cost of raw materials, cost of electronic components, and these are the revenue streams, the amount which we have predicted for per unit. Thank you. Now further, Darren will explain on this topic. One second.
Kelvin, can you present the costing? Hello. Okay, so this is the costing which we have predicted and not predicted actually, which we have done till now. Keep it portrait, I guess, or I'll zoom it in. Yeah. So the laptops, 3 laptops which we used personally.
Sorry about
Uh,
that.
yeah, it's okay. So we kept three different laptops, one for the flight controller module and one for the analysis, and next was to design. So we kept it differently. BLDC motors, this was the motors which we used, propellers, a FlySky transmitter. As of now, we have used FlySky. As Kelvin said, we have to make it indigenous, but for that, we'll take time to make our personal own transmitter and flight controllers. So it's a big industry and a long way to go. So as of now, in the 1 year schedule, we took help from the online surveys and everything, and online what we can say, online the products which we can get just to present a prototype. But if we go ahead, we'll make sure that we make it ourselves, all the transmitters, all batteries, and the frames and everything. So this is just the prime cost which we have done. Can you show the whole cost? Yeah. Including all laptops and everything, we came around to it's like two lakhs. Yeah. So this is the primary cost. And regarding the factory cost, as of now we are just students. We don't know who to approach to or who to tell about our prototype. So we just included the primary cost. But if we go ahead, we'll know who to actually get in touch with. How much should the cost be exactly, and how which industry to mainly focus. So this is just related to the primary cost. Primary cost. Yeah. Thank you.
Yes, sir. We are done now. Yes, ma'am. We are done now.
We're done with the presentation.
What?
Okay. Yeah. Um, yeah. Great job. I know there's a big market for drone manufacturing in India. So it's a good job in thinking about tapping that. Um, yeah, it would be great if you could have shown some comparative analysis, but otherwise, I think it's a pretty solid idea.
Yes, ma'am. Yes, ma'am. So actually, for the competitive analysis, we actually faced a very big problem. So since our customer is actually Indian Army and Indian Air Force, so their data they don't share. Like it's a very sensitive and secretive data they don't share. And other thing is whenever they buy components or any systems from the foreign country or from India, they just don't buy the single component. They also buy the logistics and services, and also it is very hard to track what is the pricing of each armed component or defense component. So we actually tried very hard to get the data on that, but it is very difficult to find that. But we will still keep on trying for further, because it is helpful in future.
You said your customer is whether they are your real customer or targeted customer.
Sir, can't hear you. Can sir?
Yeah. Can you hear me now?
So your voice is very low. We can't hear you properly.
Can you hear me now?
Yeah, yeah.
Okay. You said that your Indian Army is your customer. So they are real customer or targeted customer at present?
No, sir. They are targeted customers.
Targeted customers.
Yeah.
Okay. Okay. Targeted customers.
Yes, sir.
Yeah, that's it.
So, ma'am, would you like us to explain anything else, like decoy or any confusion do you have?
See, regarding this market cap, market strategies, okay, never talked anything about, right?
So, sir, marketing strategies like the most effective marketing strategies like recently the government held a competition for drones. So we for startups they can participate in these drone competitions organized by government, and the winner of these drone competitions are selected. Uh, so actually the army and the government don't like uh, they like actually tried and proven systems. So if we can prove in front of them, like in competitions and other ways or methods, then they procure the system. So for example, in this year's competition, a special drone was made that was made to that was a I think for uh, 78 kg, that could lift a 78 kgs worth of load, and it was made to transport cargoes between naval ships of the Indian Navy. So it is actually used for transporting food between naval ships. The that drone is used, and they win, and they are currently making systems for the Indian Navy. So since the army and government only take trial and proven systems, so we have to actually participate in many competitions, or we can do a private collaboration with an already big shot company, so that through that way the government will already have trust in them, and we are just providing support for that big shot company. Or the final method is that we can directly provide the patent to the army or navy, and they can do whatever with it they want. So after providing the patent, they can sell it to any company and make the components indigenous. That's what we are mainly planning, to sell the patent directly to army if possible, army, navy, or air force.
That's what you are planning, or that is your business strategy?
That is actually
you said so
yeah.
many things. You said so many things, and everything cannot be possible. So you
Yes,
have to
sir.
make it very clear whenever we talk about market strategy. Okay.
Yes, sir.
So are you just trying? First thing is whether it is patented, and you're just trying to sell the patent.
No,
Or
we
you
are trying to we
Yeah.
are trying to patent it right now.
Yes, sir. We are on the
What is the unique IP here?
What, ma'am?
What is the unique IP here? What is your intellectual
No,
property?
ma'am, we are not no, we are not patented it yet. We are actually in research and development stage. Patented any of it.
I understand that, but
We
what
are
is your what is the uniqueness of the solution?
so uniqueness of this solution is that currently in market there are only available of three kinds of decoy. So the first type of decoy is a flare decoy, which is meant to fool infrared targets. Flare is used for creating high heat signatures. Then there is a second type of decoy, that is chaff decoy. Chaff decoys are used for fooling radar technologies. So chaff launches a reflective strips of metal, which creates a cloud which fools the radar. Then final type of decoy is used is sonar decoy, in which the submarines use. create a high acoustic signature, due to which the enemy torpedoes are fooled. But our decoy is totally new, so we are making a decoy that is optically very, very similar to the mothership. So the current problem is that the AI is being integrated into a weapon system. So before this, only the missiles used to track the heat signature, and measuring heat was not very difficult. But because of AI, now the AI knows that what a enemy target looks like. So for example, a drone. So AI can determine what an enemy drone will look like. So just putting an flare or infrared decoy in front of it, the AI systems cannot be fooled. So we are making an optical decoy, which means that the
Yeah, makes sense. But
hello, ma'am.
the main question is to train any model, any AI model, you need data. And it'll be, like you previously mentioned, very difficult to get military level data. So how do you plan on training your model?
Yeah. So we don't have a requirement for AI level for gathering data on AI, because it is the job of enemies. What we want to do is fool the enemy AI systems, if possible. So our system should be as reliable as possible. It should actually, the requirement of this decoy is to optically look. If a human eye sees, it shouldn't be able to distinguish between a decoy and a human. So there should be, it's like having a fake drone and a real drone. And the human eye shouldn't be able to distinguish between them. So that's how we are planning to fool a human eye or an AI.
I'm good. Thank you.
Thank you, ma'am. Thank you, sir.
Thank you, ma'am. Thank you, sir.
Thank you, ma'am. Thank you, sir.
Can we leave?
Yes, yes, you can.
Thank you.
Yeah, thanks for the opportunity. This was a lot of fun.
Project man. Project madam. Not hearing. So shall we end now? And where we need to send that sheet which you have shared? Hello? Hello, Isel. Yeah. Where we need to send those two files? Where we need to send those two files which you have shared. Am I audible? Which email? Okay, okay.
Okay, thank you. Thanks, Das sir and Project ma'am. Talk to you soon.
That's all.